Today's lesson, section 5.4b, we'll be talking about more trig graphs. Today we'll be talking about the cosecant and secant curves. So the functions for cosecant and secant will look similar to the ones below here, where we have y equals a times cosecant of kx, and then also y equals a secant kx. Now remember, this is with no phase shift or vertical shift, so that's why it's just a and k. And cosecant and secant, they have a period of 2 pi over k. So they're kind of like sine and cosine in the same respect. Now remember, that makes sense because your sine and cosine have 2 pi, so their reciprocals should also have the same period of 2 pi. Okay? Now, when we're looking at the graph of the following functions, we're not going to graph all of them like the pi over 6 and the pi over 4, all those values. Okay? We're just going to stick with the normal values. Okay? Now, here, let's think about what... And actually, we should probably write this next to it. Let's talk about what sine and cosine are at those same values. Okay? Then we can kind of discuss what our cosecant and secant value should be. Okay? So sine, you have at 0, it's your y value, right? So plug in sine of 0, that gives you 0. Sine of pi over 2 is 1, because you're thinking about this. Okay, so you're thinking about that point, this point, and then back to that same first point. Okay, so pi, so sine of pi is 0 again. Sine of 3 pi over 2 is negative 1. And then sine of 2 pi is going to be 0. Now for cosine, cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And then cosine of 2 pi is 1 again. Okay? So now, remember that I just said that cosecant and secant are the reciprocals of sine and cosine. So, if we take those values for sine and cosine and flip them, then we should get the value that we want. So, here, remember, it's always 1 over sine, and then it'll be 1 over cosine. So 1 over 0 makes that an undefined line at 0. If I do cosecant of pi over 2, 1 over 1 is still 1. Cosecant of pi 0, so, or has a 0 there, so it's 1 over 0, which is undefined. Cosecant of 3 pi over 2 is 1 over this negative 1. Okay, so then that would still be negative 1. And then 1 over 0 would be undefined again. Okay, now, here are your graphs. That doesn't give you a lot of points, does it? So, looking at the graph right now, okay, now that doesn't really give you much to go off of where you're supposed to go next. But let's think about what the sine graph should be. Okay, so sine was 0, and I'm going to do these in orange, then 1, and then 0, and then negative 1, and then 0. Okay, so our sine graph look like this. Okay, now remember, reciprocal should be kind of the opposite of that. So for this one, now any time that that your value of cosecant or sine gets to 0, your sine graph actually becomes undefined. And remember, we want to approach vertical asymptotes with our values. So actually, when we do a cosecant graph, we do kind of the opposite picture. So instead of going towards the x-axis, you go away from the x-axis. And then same thing here on this other side. So our values start to approach infinity for a y value, but then halt at 0, pi, and 2 pi because of the undefined lines. Okay? Now let's talk about what secant should be. Okay, so 1 over cosine of those values will be our secant. So secant of 0 is going to be 1 over 1, because this is 1. Okay, so that gives me 1. And then 1 over 0 gets me undefined. Then 1 over negative 1 is negative 1. 1 over 0 is undefined. And then 1 over 1 is 1 again. Okay, so you have about as much information as you just had with the sine one. Okay, so it's the same thing. So let's draw the cosine graph there. Remember, 0 or 1, then 0, then negative 1, and then 0, and then 1 again. So then you got a graph that looks like our sine graph. Okay, so doing the same thing with our secant graph. Okay, you want to go opposite way, so the lines should approach our vertical asymptotes. Okay, so we should get a graph that kind of looks like that. So cosecant and secant look similar to one another, just like sine and cosine look similar to each other. Now the only difference between the two graphs, like between sine and cosine and cosecant and secant, is a matter of phase shift of pi over 2. Hopefully you've noticed that if you shift the graph over, like if I do secant of x, let's say minus pi over 2, then that'll get me the same thing as what secant has for just of x. Okay, and if you do the same thing with secant, you do secant of x plus pi over 2 in the parentheses, then you'll get the same graph as your cosecant graph. Okay, or as your secant graph. Now let's do a summary here, because we did the same thing with the sine, cosine, tangent, and cotangent. So remember our domain. Now here our domain for cosecant will be all reals, kind of like tangent and cotangent, except where were our asymptotes at? Okay, so they started at 0 and they went every pi. So we would say pi times k for any k that's an integer. Okay, that would be the shorthand way of saying the same thing. So k is an element of any integer. Okay, our range, now here we can't get in between negative 1 and 1, so our range is just restricted a little bit. Okay, so that would be our range. So from negative infinity to negative 1, and then union 1 to infinity, including negative 1 and 1, because we can't get those values. We don't have any zeros. It never crosses the x-axis. The asymptotes happen every time that it ruins our domain from being all reals, so it's every pi k. It has the same period as sine, so it's 2 pi, and your amplitude works out the same way. It's absolute value of a. Okay. Secant, same thing, from negative infinity to infinity. Okay, except now here your asymptotes are from pi, like you have pi over 2, 3 pi over 2, 5 pi over 2, stuff like that. So you're starting at pi over 2 plus pi k. For every k that's an integer. And here it'll do the same thing for your range. So it goes from negative infinity to negative 1. Union from 1 to infinity. Okay? It also doesn't cross the x-axis, so there are no zeros. Its asymptotes happen in the same place that it disrupts our domain. So pi over 2 plus pi k has the same period as cosine, so it's 2 pi. And the amplitude is absolute value of a. Okay? Have fun.